Hey, what's up everyone? Welcome to this new live called What are the basics of Swift UI? So you've seen it from the title and the thumbnail. Today we are not going to talk about complex stuff, and instead I just want to walk you through, well, what are the basics principles behind a Swift UI iOS app. So let's get started and let me get rid of the thumbnail. So as you can see, I'm on a web page and I'm actually on a tutorial made by Apple with the purpose of explaining what are the basics of a SwiftUI app. So if you want to check out this tutorial, you've got, of course, the link to it in the description. Finally, last thing before I get started, if you're watching live, don't forget that there is a chat, and at any point, if you have a question or if you want to make a remark or anything else, please feel free to drop me a message and I will do my best to answer it as best as I can. So let's get started and let's see what is the outline of this tutorial. So here we're going to learn SwiftUI and we're going to discover tips and techniques for building multi-platform apps with this set of conceptual articles and sample code. So let's scroll down a bit. And you're going to see that the tutorial is, if I remember it correctly, split into 3 chapters. So the first one is about app principles and it's going to walk us through the building blocks of a SwiftUI app. So we're going to explore the structure of a SwiftUI app and we're going to specify the view hierarchy of an app using something called a scene. Then we're going to have the chapter 2, which is about view layout. So we are going to learn how to display content in views that will adapt to their environment. And so we'll see how we can maintain the adaptable sizes of the built-in views of SwiftUI. We're going to see how to layer our content, how to choose the right way to hide a view, so kind of like a best practice, and how to organize and align content on the screen by using stacks. And yeah, chapter 3 is the final chapter. It's about state and data flow, and we are going to delve into the principles of managing app state and data flow, and we'll see how to drive changes in our UI with state and bindings, how to create a custom input control that binds to a value, so kind of like a text field, for instance. And finally, how to define the source of truth using a custom binding. And that will be it. So this tutorial is quite short, actually, when you compare to other tutorials from Apple. So I think, I don't know, I guess it's going to take us between 1 or 2 hours, and we'll see in the end if I was right on that guess. And so then we have some resources, so documentation, sample code, Xcode, videos, and forums. But I guess we're going to go over them as we walk through the tutorial. So let me get started with the first chapter and the first paragraph, so exploring the structure of a SwiftUI app. So here we're going to talk about, it reminds us of what SwiftUI is. So SwiftUI is a declarative framework that helps you compose the user interface of your app. The principal building blocks that form the structure of a SwiftUI app are the app, the scene, and views protocol. This sample introduces you to these protocols by walking through lines of code and explaining what's happening and why. To experiment with the code, download the project files and open the sample in Xcode. So I've already downloaded the sample. You can see that Apple recommends using Xcode 14 beta, so I'm going to do it also. I guess maybe you could do it with Xcode 13 for the most part, but it's possible that in this tutorial they use new APIs that are specific to either iOS 16 or the latest version of Swift. So first section is app structure. An app structure describes the content and behavior of your app. And each SwiftUI app has one and only one main app structure. This sample defines its app structure in the myapp.swift. Let's take a look at the content of that file. So when they say structure, I think they mean it in the sense of a struct in Swift. So I've downloaded the code in Xcode also. So it's right here, but I'm going to go over the website for now because it has everything that we need. So this is the content of the file. And they say step 1, to access the symbols and features of SwiftUI, the app uses an import declaration to import the SwiftUI framework. Okay, up until now is pretty standard. And if you want to learn more about other import declarations in Swift, you can follow the link. Step 2, to indicate the entry point of the SwiftUI app, the sample applies the @main attribute to the app structure. So we can see we have a struct called myApp. It inherits from that protocol called app, and it's also annotated with @main. And so this is what lets iOS know that this is the entry point of the app, meaning this is the code that should be executed when the user launches the app by tapping on the icon on the Springboard. So the entry point is responsible for the startup of the app. And an important point, they say, is that the SwiftUI app contains one and only one entry point. Attempting to apply @main to more than one structure in the app results in a compiler error, which makes sense because the entry point, there must be only one because this is what iOS will use to start your app. Okay. Step 3, we can see that the myApp structure conforms to the app protocol and provides the content of the app and its behavior. So right here, the struct called myApp, it conforms to the protocol app. Step 4, the structure implements the computed property body, which is a requirement of the app protocol. So this property returns the content of your app described as a scene. A scene contains the view hierarchy that defines the app's user interface. SwiftUI provides different types of scenes, including window group, window, document group, and settings. Here, this sample uses a window group, so we can see it right here, a window group scene to represent the main window that the app displays. SwiftUI provides platform-specific behaviors for window group. For instance, in macOS and iPadOS, a person can open more than one window from the group. And in macOS, a person can combine multiple instances of the window group into a set of tabs. So it's true that on iOS, things are actually pretty simple because your app has only one window. But on iPadOS, you can have more than one window. Think, for instance, about Safari, where you can open 2 instances of Safari in split view. And on macOS, you can even go further and you can create several tabs. For instance, the Finder does it. Even Xcode does it, actually. I'm not sure it uses SwiftUI for that, but Xcode lets you create tabs. So here we have a little tip. If you're creating a document-based app, such as a word processor or text editor, you can use the document group scene to open, save, and edit documents. For more information, see Building a Document-Based App with SwiftUI. So I'm going to add that link to my reading list because it could be interesting. Here we're not going to do that. And actually, I think most of the time we build apps that are based around APIs, so not really document-based app, but it could be interesting to give it a look someday. Step 6. So the scene contains content view. So right here, a custom view that creates a view hierarchy that consists of an image and text. So let me check. Yes, you can see it. It's in the frame, so you can see it right here. And it's really the great thing with this tutorial is that they show you what the app shows straight in the web page. So you can alternate between Expo and the web page, but you don't even have to. Keep reading to learn how content view composes the view hierarchy. Okay, so up until now, we've seen that we have at the top level a struct called myApp that implements the protocol app that is annotated with @main in order to be the entry point of the app. The protocol app requires us to have one property that is here a compute property. It's called body and it returns a scene. That scene is a window group and inside it we have a custom view which is called content view. And now we're going to see what is this content view. So let me keep scrolling. So we are at the section 2, content view. In SwiftUI, a scene contains the view hierarchy that an app displays as its user interface. A view hierarchy defines the layout of views relative to other views. In this sample, a window group scene contains the view hierarchy that content view composes using other views. So we can see it being drawn right here. So we have the window group that contains the content view, that contains a vstack, that contains both the image and the text. So we are definitely in a hierarchical representation. Let's see what is next. So here we have the code of the content view. So the source code begins by importing the SwiftUI framework. We are familiar with it, and they specify us, they remind us that without the import declaration, content view wouldn't have access to symbols in SwiftUI. Step 2, content view is a struct that conforms to the view protocol. So the view protocol is no surprise, it's a central part of SwiftUI. A view defines one or more visual elements that appear somewhere on a screen. A view is typically made up of other views, creating a view hierarchy. So we can see the idea of composing simple views into more complex views is starting to pop up. Content view implements the compute property body. So right here we can see the same name than for the protocol app, but there is a difference, which is that in the app protocol the body was a scene, and in a view the body is another view. So the protocol view, we could say, is a recursive definition. So content view implements the compute property body, just like the myapp structure does in the previous section. Actually, that's what I was saying. Implementing body is a common pattern that you see throughout your SwiftUI code. For instance, when a structure conforms to protocols such as app, scene, and view, they all require you to have a body. So body is really a central ID in SwiftUI. It's as important as a UI view or UI view controller would be in UIKit. Next step, content view contains the SwiftUI provided view vstack. So vstack is part of SwiftUI, and it's a view that arranges subviews vertically. So vstack simultaneously renders any on or off-screen views it contains. Using a vstack is ideal when you have a small number of subviews. However, if your app needs to display many more subviews, consider using lazy vstack, which only renders the views when the app needs to display them on screen. A note here, lazy vstack was introduced with iOS 14, so if you have to support iOS 13, you won't be able to use it. But also, if you have to support iOS 13, I don't recommend you use SwiftUI in production because there are too many limitations and bugs on that first version that supported SwiftUI. So here, as an experiment, they suggest that we replace vstack with either hstack or lazy hstack to arrange subviews horizontally. So for this, I'm going to go back to Xcode. So let me go into content view. Let me display the preview. So for that, you do Command, Alt, and Enter. Why doesn't it appear? Why is it always when you're doing a live that there is an issue? When I try to show like the preview, okay. Yes, canvas. Okay, it doesn't want to show the canvas. I'm going to launch the app in a simulator. That's the next best thing I can do. So simulator is here. I'm going to make it a little bit smaller so that it can fit on the screen. I'm going to make it so that it always stays on top. Hey, Wilfried. Yeah, definitely agree. And actually, I found out about this tutorial very recently. And I was like, whoa, that sounds cool. Let's do it live. Okay, so maybe actually I've downloaded the new beta from Xcode 13, like from Xcode 14, yesterday, and I had never launched an app with it, so that might be why the preview was not working. It still needs my permission to launch the app. Okay, going to make the simulator slightly bigger. So we have the simulator right here. You can see things are laid out vertically, and if I change that vstack by an hstack, it should be laid out horizontally now. Let's see, but there isn't too much of a suspense. Yes, so we can see now things are laid out horizontally. Okay, let's get back to the tutorial now. All right, next step. So we are taking interest in the first subview of the vstack, which is the image. So the image, you can see this is, so I guess the preview shows exactly what is highlighted. So only the image without the modifier called on it. So the first subview in the vstack is image, a view that displays an image as the name suggests. The sample displays an image of a globe using the initializer method init system name. This method creates an image view that displays a system symbol image. Symbol images like globe come from SF Symbols, a library of icons that you can use in your app. So actually, that was one of the very nice addition of iOS 13. Also, this SF symbols library of icon, and they keep improving it with every new version of iOS. And it allows you to have access to icons like this without needing to add like any kind of resources into your Xcode project. Okay. The content view applies the modifier image scale. So here, to the image view to scale the image within the view to the relative size image.scale.large. So experiment, change image.scale.large to another scale size. So let's go back to Xcode. So let's see what other options do we have. Okay, we have large, medium, and small. So what I'm gonna do is that I'm going to relaunch the app in the simulator so that we can see like what it looks like when it is large. So you can see that large is not that big, okay? If I make it small, just how small is it going to be? Let's see. I don't see that much of a difference. Is there a difference? Like here, it's a little bit less than the cursor of my mouse. And if I put it large again, okay, yeah, it's actually gotten like bigger, but I think not by that much. Let's see what they suggest next. I'm going to get rid of the simulator. Okay, then they talk about the second modifier. So modifier, I don't think they've defined what they are, but the modifiers, they are methods that you call on a view. The modifier is going to like, as the name suggests, modify the view, but it's going to add it either a behavior or a configuration. And the important thing is that the modifier will return a new view. And this is what allows you to chain modifiers one after the other. And it's a pattern that you will see a lot in SwiftUI. So the second modifier is foreground color, and it adds color to the image view. As you can see, when we add the accent color, so it's a built-in color of iOS, now the image has become blue, and it's the same blue that is by default the color of a UI button, if I remember it correctly. So in this sample, content view applies the semantic color accent color, which reflects the accent color of the system or app. To learn more about color representations, see color. So color is the type in SwiftUI that represents a color. So it's the equivalent of UI color in UIKit. Experiment, change the foreground color to another semantic color, such as primary or standard color like teal. So let's see. So here the color is the accent color. If I change it to primary, I guess it's going to be like, so like it's a primary color for text, so it will be just like the text, so white on light on dark mode and black on dark mode. Let me relaunch the app to check. Okay, that's indeed the case. And if I switch from light to dark, yes, indeed, that's the case. And if I set, we could say an absolute color, so teal, for instance, we should see that color also appearing on the image. Perfect. Okay, let's go back to the tutorial. Then we have a second subview in the VStack, which is text, and it's another very important view in SwiftUI because, as the name also suggests, it's a view that displays one or more line of read-only text. So we can replace the text. So for now, it says hello world. Actually, let me also put it back as a VStack. So here we have hello world. And instead, I'm going to say, for instance, I don't know, I'm going to use my first name. So I'm going to say hello Vincent. And when you change the string that you pass, it changes the text that is displayed on the screen. So pretty straightforward up until now. Then we can see a last modifier that is this time applied on the VStack. It's called padding, and it adds a platform-specific default amount of padding, that is amount of space to the edges of the stack view. So padding, it's like an inner margin. And so you can specify which edges and amount of padding to apply by providing edges and length parameter values. For instance, we could say padding for the bottom and trailing edges of 20. So we could change it. If I change it, let's see if it's going to like be reflected in the code actually, because here actually the view doesn't reach the border of the screen. So like I can change the padding. So for instance, I could say I want a padding like on the vertical edges and I want the value to be, I don't know what the value, I don't remember the signature of the modifier. Let me see. So padding, and it would be, okay, that can be like, the suggestion is not that great here. Let me get back to the web page. So there was, okay, there is no name for the argument. So I would just do like vertical and like 20, for instance. Okay, so there is a big padding. Maybe if I put a big number, we should see the view being pushed down, I guess. Let's see. No, we don't see it being pushed down by too much. And even if I was to say 200, but I guess it's adding. Yeah, it doesn't do anything because actually the padding is being added right here. But given that there is nothing above, it doesn't do anything. Maybe if I put like a really big value, like, I don't know, like 800, for instance. Now, because there isn't like, isn't anything above. So I'm going to set it back to how it was. Okay, like that. And now we're going to go back to the tutorial. I'm going to also reduce the simulator. Okay, and so when you run the sample app, it displays the scene that contains the view hierarchy described in content view. So experiment, build and run the sample using Xcode. So we just did it more than once. Then play around with code by following the suggested experiments mentioned in the previous steps. So we've done everything for this first chapter, for this first section. Next, we will learn how to specify the view hierarchy of an app using a scene. Okay. So a scene contains the view hierarchy of your app. SwiftUI provides building blocks that help you create the user interface of your app. One of those building blocks is scene, which contains a view hierarchy that defines the user interface of your app. You can specify your app's view hierarchy in a scene that SwiftUI provides, or you can create a custom scene. This tutorial walks you through both approaches. So once again, I have to download a project. So I'm going to do it actually, because I always rather like start with something that is clean. So I've downloaded the project. So it's called specifying the view through a scene. I'm going to quit Xcode and open the new project. Of course, it's trying to open it. Yes, it's trying to open it with the non-beta version of Xcode. So I'm going to change this. Okay, that should be better. So what's interesting here is that they're going to have us create a custom scene, and actually that's something that I've never done up until now. So I'm actually curious to see what we're going to do with this custom scene. Okay, so section 1 is adding a scene to the app. So the sample uses a journaling app as an example. To describe the view hierarchy of the app's user interface, the my app structure declares a scene and its content. Let's take a look at the structure and its scene. So this is the file myapp.swift in the project I just downloaded. So first, and just like in the previous sample code we were using, the sample defines an entry point using the @main attribute and the structure myapp, which conforms to the app protocol. So right here, line 3 and 4. Note, the entry point and myapp structure are responsible for the startup of the app. Each SwiftUI app has one and only one entry point and main app structure, and I think by now we've understood it. Step 2, the myapp structure implements the compute property body, which returns a scene. So just like before, and one information they give us is that the compute property body can return one or more primary and secondary scenes. That's interesting. We'll see if we get to return more than one scene at some point. Step 3, in this sample, body returns the primary scene window group, which describes the view hierarchy of the sample's main window. The window group scene is one of the more commonly used scenes. It provides platform-specific behaviors for your app, such as supporting multi-windows in macOS and iPadOS. For more information about this scene, as well as other scenes SwiftUI provides, see scenes. So this is a link to the documentation. Step 4, so we have the root of the content of the scene. So the root node of the view hierarchy is tab view, a container that provides tabs that people can use to switch between different subviews. So it's the equivalent of UI tab controller in the UIKit world. The tab view contains two subviews, content view and setting view. So we can see them right here. Both are custom views. Content view displays a list of journal entries, and settings view displays other views that let people edit the settings for the app, such as the account associated with the journal. Okay? Each of these views applies the tab item modifier, which tells the tab view the image and text to display in each tab. And so here we can see what it will look like when it is displayed by iOS. Step 7, when the sample app runs, it displays the view hierarchy described in the window group scene, which is a tab interface with two tabs, journal and settings. And so actually, I'm going to go into the sample code and I'm going to run it. So on an iPhone 13 Pro. So this is the scene it's using right now. So I'm waiting for the app to start. Okay, and we can see we have the scenes, which is the entire window. Then we have the tab view with the two tabs. So here we have the content view being displayed. And if I tap on settings, we can see that we switch to the settings view. Okay, let me just see if the previews are working again. No, even restarting Xcode did nothing for that. That's too bad, but we'll keep on using the simulator. Okay, so defining another view hierarchy. The sample app runs on multiple devices, including iPhone and Mac, which are arguably two very different kind of devices. And you're saying, Wilfried, that tab view can also be the equivalent of UI page view controller, depending on the tab view style modifier. That is absolutely correct. And it's one of the not hidden, but superpowers of tab view, that you can also use it as a page view controller indeed. Only thing that could be a bit different is that a page view controller, it can work very well with an infinite number of pages because it only asks for the next and previous page. I'm not sure that a tab view would be optimized for a very, very large number of pages, but actually I'm not sure. It would be we would need to test it to see. But that's a very good remark. So, resuming, the view hierarchy described in the previous section doesn't look quite right in macOS, so the sample declares another view hierarchy that takes advantage of features specific to the Mac. So if we look inside my app, we can see that there is here the view hierarchy that we saw in the previous section. So the window group with the tab view and then the two views. And we can see that it is enclosed inside an hashtag if OS iOS block of conditional compilation, which means that when we build for iOS, this code is being built. And when we don't build for iOS, but we build for macOS, that code is being built and the other code is being ignored by the compiler. So let's see. Indeed, nothing else to see here. So let's look at the view hierarchy the sample defines for macOS. So let me get rid of the highlighting. So the sample defines the other view hierarchy in window group scene. Okay. And so we have an alternative content view. And then, unlike the previous view hierarchy, the root node of this hierarchy is the custom view. Yes, alternative content view. So we don't have the equivalent of the tab view. Exactly. The root node of the previous view hierarchy was the tab view. So exactly what I was saying. And the sample uses the secondary scene. So it's a second scene that is returned in the same body, which is this time a settings scene to provide a menu settings menu item that's available in the app menu, which is a common feature of Mac apps. So the settings scenes is only available on macOS. So actually, let me get back to Xcode and let me try this time to build my app for the Mac, actually. Okay, I need, of course, a signing certificate to do that. Let's see if I can manage to solve the issue while we are live. So I'm going to use my own team. It's able to create. Perfect. Okay, it wasn't that big of an issue. Build succeeded. Perfect. So the app should launch any minute. And yeah, like you're saying, like basics is not so basics because it's talking about macOS app right from the get-go. But at least we will have a complete picture of what we can do with SwiftUI. Ah, damn it, to launch it with Xcode. Because I don't have Ventura installed. Let's see. On the version of macOS, yeah, let's go for another one. Like if I do 12.4 instead, do I have to do it? No, I think that should be good. Let's see. Yes, perfect. I've been able to launch it. So I guess there wasn't like any specific API it was being called. Oh, there is a crash. Okay. Okay, symbol not found. That's not a good sign. Let me just clean to see. And if it doesn't solve it, I guess like I don't have the version of macOS. Yeah, here it says build failed because it uses navigation. Okay, it uses API that are only in Ventura. So I won't be able to run it on the Mac. We will have to only like satisfy ourselves with running it in iOS. Okay, back to the tutorial. But using the settings scene as a secondary scene would have enabled us to have the settings item in the menu, and with the standard shortcut also, which is Command comma. So the settings scene contains a custom view setting view, which displays app settings in a window that the settings menu item provide. So we can see that this time the settings view is the same between iOS and macOS, but it was not the case for the content view. So with two separate view hierarchies defined, the sample must specify which one to use based on the target platform. Because maybe you've noticed every time the tutorial was talking about view hierarchy, it was always saying the view hierarchy or your app's view hierarchy, but it was always using a definite article, and it's not by chance or random that they do that. It's because your app can only have one single view hierarchy. And so here what's being used is what I described just earlier. We use a conditional compilation block to tell the Swift compiler to conditionally compile the code block depending on the value of one or more compilation conditions. And here the compilation conditions are for which OS we are building for. And here we can see that the app uses a separate platform conditional to compile the scenes that the Mac app uses. So here is how the scenes appear when you run the app on iPhone and Mac. So we won't be able to run it on Mac today, but this is what it would have looked like. And we can see that the iPhone version of the app displays a scene with a tabbed user interface because it uses a tab view, while the Mac version displays a scene with split view interface. So right here, the Mac app also displays the secondary scene settings when you select the preferences item under the app menu. So I hope they're going to make us focus on how the navigation is implemented to understand why is the iOS app implementing a navigation based approach, so where you are pushing and popping views onto a navigation stack, and on the other hand, the macOS app is using a split view pattern. Let's see. Section 3 is creating custom scenes. So the source code in the My App struct does the job of defining view hierarchies, different versions of the sample app. Is there something wrong in that sentence? The source code in the My App structure does the job of defining different versions of the view hierarchy of the sample app. Yeah, maybe there's something wrong in that sentence. But the code, or it's just me that is tired. But the code is lengthy, making it difficult to maintain. One improvement that can help make the code more readable and easier to maintain is to use custom scenes. So instead of having like all that logic of hashtag if OS iOS and that kind of thing, we could create a custom scene that would encapsulate all of that. So a custom scene is one that you compose from other scenes. So Step 1. To describe the scene that displays on iOS device, the sample includes the custom scene, myScene, which is a structure that conforms to the scene protocol. So here we have myScene, and inside we have what was basically implemented in the body of my app before. So it's always a bit confusing in which file we are, because all of these files, they all implement a body. So it's important we pay close attention to which file we are currently on. So a struct that conforms to scene must implement the compute property body, just like structure that conform to the app protocol do, or also struct that conform to the view protocol do. Okay, I'm glad to see that it's not just me that is super tired. There is something weird with that sentence. So the implementation of body uses the same code from the my app struct covered in the add scene to the app section of the tutorial. So it's something we've already seen. It's something we've already seen for the scene. That's not a very good joke, but we do what we do with what we have. Step 4. For macOS, the sample includes another custom scene, my alternative scene, so another struct that conforms to the protocol scene, which is another struct that conforms to scene. And inside of it, we have the scene for macOS, so it could have been called my macOS scene instead, for instance. And inside, so actually what's interesting is that here we have the window group, and only if we are in macOS, then we have the settings. It's possible actually that settings is only usable on macOS. That could be possible. So it too implements the compute property body, as we've just seen. The code for this scene is the same code from the my app struct discussed in the previous section. The computed body property includes the secondary scene settings. This scene is only available in macOS, so actually that's the case. It's only available in macOS. And so that's why it has to be placed inside a conditional compilation block, otherwise the code would not build. They could have also chosen like to put everything inside the body, inside the macOS compilation code. I guess it could have been like possible. I don't know if there is a good reason not to do it, because I'm not sure that we want to use my alternative scene if we're not on macOS, but at least they've made that choice. Let's see where it leads us. Next section is refactoring the code to use the custom scenes. So with the my scene and my alternative scene in place, the final step is to refactor the code in the my app structure so that it uses the custom scenes. So this is my app, and this is what we're going to refactor. So before refactoring the my app struct to use the custom scenes, the code is fairly long and complex. Indeed, because there is both the code of two view hierarchies, there is also the code to deal with the conditional compilation, is being a little bit, it's starting to get crowded in there basically. So this approach, the current implementation, so the current crowded implementation, can make the implementation of compute property. This approach can make the implementation of compute property body more difficult to maintain. However, after refactoring the code, the my app structure is easier to read and maintain. So I guess when I will scroll down, we will see the refactor. Magic. So now if it is iOS, we show my scene, which is a scene, and if it is macOS, we show my alternative scene, which is also a valid scene. And so I guess they could have put the entirety of my alternative scene inside an hashtag if OS macOS block, because it's only used inside another one of those blocks. Okay, experiment, change the code so the sample uses my scene in macOS and my alternative scene in iOS. So let's try and do it. Of course, we're only going to be able to do the second one, because as you've seen, I cannot run the app on macOS. So if I go inside my app and I say, okay, I want to use my alternative scene also in iOS. So first, let me run the app as it is now, so that we have it under the eye. Okay, I'm gonna make it a bit bigger. So we have the app with the tab view and the two tabs. And if I use my alternative scene also on iOS, so let's see. We no longer have the tab view, and the settings are no longer accessible, which makes sense because if I go back to the code inside my alternative scene, you can see the settings, they are in this block of conditional compilation. And so when I build for iOS, that code is completely ignored by the compiler. Okay, let me go back to the tutorial. And it seems we've finished this section. So are we back to, are we up? Yeah, we are in the second chapter. So maintaining the adaptable sizes of built-in views. So to keep your app's view layout fluid on any device for each type of content, so you want to keep your app's view layouts fluid on any device for each type of content your app displays. So you want your app to display well and to display well as to display well both on small devices like iPhones or even smaller like a watch, an Apple Watch, but also on larger devices like iPads and even larger Macs. So the views you define with SwiftUI either directly contain views that SwiftUI provides or use custom views that contain these built-in views. SwiftUI views determine their own size, and understanding how to modify the size of built-in views while preserving their adaptability is the best way to create a fluid layout without complicating your code. Okay, so first it talks about text and symbols. So when defining the layout for your app, text and symbols play a central role in conveying information to people, in navigation links, button labels, tables, and more. Text and symbols display information or label other elements need to have enough space to display their content. Basically, you don't want your text to be truncated with the ... that we all hate to see in an iOS app. So first, for the text view. So a text view displays read-only text. Its content could be a short string, like the title of a play or the heading of a section. A text view could also display a much longer string, like all of the actors' lines for a scene in the play. When you declare a text view in your layout, give the system semantic information about your text with the font attribute. So font is the equivalent of UI font in UIKit. The system chooses font faces and sizes so that, for example, a text with the title font is more prominent than one with body or caption. So we have this SwiftUI code right here. We have two texts. The first one is for title and it's Hamlet, and the second one is for a caption, something much smaller, and it's by William Shakespeare, and it renders as this. And as you can see, the title is much bigger than the caption, which is what is intended, because semantically a title is more important than a caption is. A text view can adjust to some space constraints with line wrapping or truncation, but it doesn't change font size to accommodate situations where its ideal size is smaller or larger than the available space. So it's going to try and put words on a new line or just truncate the string, but it will not make the font bigger or smaller, even if it has more or less available space. For more information about localization, see Preparing Views for Localization. For guidance about supporting dynamic type, see Applying Custom Fonts to Text. And if you don't know what dynamic type is, it's an activity feature that's been in iOS for quite some time now, and it's the ability to say in the setting that you want the text to be bigger than it normally is. And so your app needs to be prepared for it, because the user could ask for the text to be bigger than what it was in the design you had originally implemented. Okay, now let's see how it works with symbols. Symbols, such as the iconography that SF symbol provides, can denote common app features like folders, heart shapes for favorites, or a camera icon to access the camera. Effective symbols streamline your app's UI and are easily recognizable by the people who use your app, and also people who use iOS, because the point of SF symbols is to have shared icons across several apps. You can customize their colors and sizes using standard view modifiers provided in SwiftUI. Even though you specify a system or custom symbol in an image, treat SF symbol more like text, because I guess under the hood it is implemented by a font rather than by some PNG images. To adjust the size and weight of a symbol, specify a semantic font like title, just like you would for a text view. So the following example uses an H tag to create a row of 3 image views that display icons from SF symbols. So we have the folder with the little plus icon, we have the heart that is kind of like a favorite. It's very similar to an icon that you can see on LinkedIn, for instance. And then we have the little alarm clock. We can see that it uses symbol rendering mode multicolor. So this way, like there are several layers in each icon, and they can be colored differently, which is a very nice feature of SF symbol added with iOS 15, if I remember it correctly. And they have been given all of these images the font large title. What's interesting here is that you can see that the font modifier is applied on the H tag and not on each image, and that's because you can factor out a modifier and call it onto a parent modifier. And basically what's happening under the hood is that a value in the environment, in SwiftUI's environment, is being set, and we'll see if later on that is explained in this tutorial or not. Then it comes to labels. So labels is a tag that was introduced in iOS 14, if I remember it correctly. And so when you need to use both text and a symbol to represent a single element of your app, you can use a label. So it's kind of like an H tag with both an image and a text. So a label takes care of matching its title and icon sizes and also managing their alignment. The following code defines a label that combines an SF symbol of some books with some text for its title. The label applies the large title font to both the icon and the title. The title and icon style tells the view to display both its title and icon, overriding any built-in or custom label style that the containing view might specify. So here in the label, we have both the title and the system image, and you can see both are being rendered here with the label style, title, and icon. So this can be quite useful in more than one place, because actually the pattern of having a title and an icon that kind of like gives a visual representation of the title is quite common. Just one thing to not be confused is that label is a view, but there are also several APIs in SwiftUI that have an argument called label, and in that case, it's often any kind of view. For instance, the button takes an action and a label, but that label argument does not have to be a label view. It can be any kind of view, and that can be something that is a bit confusing when you are getting started with SwiftUI. Then let's see, it talks about controls. So views that people interact with come in discrete sizes to maintain consistency when several elements of the same type appear together, like in a settings pane. Controls also need to be large enough for people to accurately click or tap. You can use view modifiers to choose among these sizes. For example, you can use the control size to modifier to make a control smaller or larger. Or you can use the progress view style modifier to choose a linear or circular appearance for a progress bar. The following example shows a picker and a button with different control sizes value. So here we have a VStack. In that VStack, we have two H tags, and it seems they all have the same content. So a picker with a title, which is choice, and then a button OK. And we can see that on both H tag, the modifier control size is called, but with different sizes. So mini for the first one and large for the second one. And we can see that SwiftUI makes it so that all of the controls grow and are aligned in a way that makes sense. For instance, the picker and the button gets bigger. I don't think the title gets bigger, but it gets vertically centered with the picker and the button. This way, like, it looks harmonious when you see it. So these are general purpose controls like menu and link, and specialized view like edit button and color picker. So all of these things are what falls under the term control. Just like in UIKit, actually, UI buttons, UI stepper, all these things, they were also subclasses of UI control. Use these views to provide familiar UI elements rather than creating custom control that you need to maintain. To explore more of these built-in views, see control and indicators. And so here they raise two very valid points. The first one is that the advantage of using built-in provided control is that users are already familiar with them because they appear inside Apple's first-party apps. They also appear in all of the other apps that use them, so that the first good reason to use them. The second one is that you don't have to maintain a custom component, which is always extra work. And the third one, and it's sometimes the one that we don't think about, is that all of these built-in controls, they come with accessibility built-in and working. Whereas when you implement your own control, you need to implement accessibility yourself, and most of the time we don't always do it, or we don't always do it well. And basically, for all of these reasons, it's always better to use a built-in control whenever you can. Next, we have images and shapes. So graphical elements, such as images and shapes, can add a level of visual enhancement for your app. This can vary from product images for a shopping app, achievements for a game, or a dynamic background pattern you create by layering and aligning various shapes. So for images, display photos and other rich graphics in an image. So image is a view. We've used it several times in this tutorial. By default, an image displays the asset's original size. You can add modifiers like resizable and scale to fit or scale to fill to scale it to the available space. So you do resizable and then scale to fit. Actually, I didn't know about these modifiers. I've always done like aspect ratio and then things like content fit. But maybe these are new modifiers in iOS 16. That could be very possible. And the thing to remember is that by default, an image will display at 100% of its size. So usually it's not what you want, because most of the time your images are a bit bigger than what you are displaying on the screen. And so you need to remember to call the modifier resizable to make the image resizable by calling other modifiers to specify how it should be resized. If you're accessing an image asset from a server, use async image to handle the download while keeping your app responsive. And remember that async image, unfortunately, was introduced with iOS 15, so you can't use it on iOS 14 and below. For more information about working with images, see fitting images into available space. Okay, now we're talking about shapes. So SwiftUI provides several common shapes and modifiers to change their size, color, or other aspects of their appearance. Use a single shape or a composition of multiple shapes to create a background, border, or other visual element. You can define a shape size with modifier like frame, which takes a lot of possible arguments, so don't worry, they all have default values, so you can only provide the one you are interested in, but basically you have the mean, ideal, and max width, the mean, ideal, and max height, and the alignment. Or to allow it to fill all available space. And that's the point they haven't mentioned in the tutorial up until now, but there are two kinds of views in SwiftUI basically. You have fitting views that only take the space that they need, and you have filling views that take all the space that's available to them. And shapes are an example of a filling view. On the other hand, text and image, they were fitting views because they would only take the space that they needed. So the following example shows 3 different shapes. The foreground color on each shape customizes that shape's fill color. The rounded rectangle includes values for the corner radius and style parameters to define the rounded corners. The H tag provides some default spacing between each shape, and to give each shape a square space to fill, the aspect ratio modifier makes the H tag 3 times as wide as it is tall. So let's take a look at the code. We have an H tag. Inside, we have 3 built-in shapes, so rectangle, circle, and rounded rectangle. So we can see rectangle is right here, circle is right here, and rounded rectangle is right here. And we can see we have the corner radius and the style of. So again, the style is how is the corner radius applied. Like it can be either like continuous, so like it is here, or it could be something like a more of a basic corner radius. So here, basically, I think when you say continuous, it draws what Apple calls a square curl. So, you know, like the corner radius, which are like very continuous and kind of like looks nice to the eye. And then we have more examples of all the possibilities of composing shapes in drawing path and shapes. Okay, next step is going to be about layering content. So you define views in an overlay or background to adapt their layout to the primary content. Designs that layer content often specify that some content stays within the bounds of other content or maintains a specific margin around that content. You can define these relationships between views with overlay and background modifier. These are two very important modifiers in SwiftUI. For example, if your design includes a graphic that provides contrast behind some scene, you can define a layout so that the graphic adapts its size and position as the text updates. You can wrap text to fit within the width of another view by defining the text in a background or overlay of that other view. So let's take a look. We need to experiment with the code. So I'm going to download the project. I'm going to quit Xcode. Yeah, Xcode has been exited. So this one is called layering content. So I'm going to open the project with Xcode beta this time. I'm remembering not to make the same mistake twice. Okay, getting rid of the previous project. Okay, perfect. This way I can interact with the project if needed. But let's go back to the web. Let's go back to the web page in the meantime. So first thing we're gonna do is defining an overlay. So to implement this layered view hierarchy we can see here from a perspective. So when you arrange content on the z-axis, you can use a z-stack or an overlay or background modifier, like overlay or background respectively. A z-stack sizes each item based on the available space without consideration for the other views in the stack. To specify that the size of some content depends on the size of other content, define this secondary content inside one of the overlay or background modifier. So basically what they're saying is that when you do a z-stack, all the items are going to be layered, each at their own size, but it won't consider the sizes of other items. But if you want the sizes to match, you're better off using the modifiers overlay or background. That's how I understand it. I might be wrong, we'll see. This example presents a photo. So right here, I'm getting ahead by scrolling too much. This example presents a photo with a block of text over the lower portion of the photo. So that thing right here. To improve readability of the photo without completely obscuring that portion of the photo, there is a mostly transparent background behind the text, right here. The text wraps to fit within the width of the photo. The text background sizes sizes to fit around the text. There's too many times the word text in that sentence. The caption photo view arranges the image and provides the text to a caption view in the images overlay. So let's take a look at the code. So we have caption photo, which is a custom view that defines the layout of a photo, and another custom caption view, which defines the layout of the caption text that appears on top of the image. Okay, so this is the code that produces this view. So the view defines an asset name property to hold the name of the image asset. The view also defines a caption text property to contain the caption text that it eventually passes along the caption view. We can notice that they are both let constants, so they don't change over the lifetime of the view. Okay. The image view initializer retrieves a photo or graphic by name from your app and display it. So it's not a dynamic resource loaded from the internet. It's an image that is stored inside the bundle of the app. By default, an image view displays an image as its original size. The resizable and scale to fit modifiers adjust this image to fit within the available space. The scaled image is the only view at the top level of this body. So the image determines the size of the caption photo view. Okay, so that's interesting, which is that the style of the view is entirely defined by the image, and even if the overlay were bigger, like it wouldn't make the caption photo view bigger, which is different if we had used a z-stack, I think. Step 6. The caption custom view defines the text and its background. So we have caption right here. And defining the caption inside the modifier overlay, so right here, declares that the caption belongs in front of the image. So it is an overlay over the image. The size of the primary view limits the size of the overlay that modifies the primary view. So basically the overlay has for its available for its available space only the size of the image and not, for instance, the white part around it. Specifying an element of bottom, so just like we do right here as an argument of the modifier overlay, is going to push the content of that modifier to the bottom center of the primary view. So like we see it right here. And it seems that you see it's the bottom center, they say, so it's not like, it doesn't like touch the bottom edge. There is some kind of padding being applied, and I guess it's a default value, or we'll see if there is like a padding provided later on. We will see. Note, an overlay can be smaller than the view it modifies, and here that's the case because it's smaller both in terms of width and also in terms of height. Okay. Clipping the view to a rounded rectangle rounds the corner of the image without changing its size or position. So it's basically we are applying a mask, basically. Change the corner radius value to a larger number to see its effect on the photo's corner. So let's do it. Let's do it in Xcode. So we are inside caption photo. Oh, look. Seems this time the preview is working. That's amazing. Yes, because I'm selecting the Mac, so of course that was not going to work. But let's see if it could work with iOS. It would be pretty amazing. Seems to be working. Let's see. I'm like crossing my fingers. Perfect. I would just like to make it dark appearance. Yes, much better for the eyes. Okay, so line 25, there is the padding. Oh, that's nice. Okay, damn it. Of course, there are some issues. Okay. It seems we have some problems. Let's see if it's gonna work or not. So if I make the corner radius, so now it's 10, let me make it 20, for instance. Okay, you can see now it has increased. If I make it 50, yeah, the corner radius is getting even, the view is getting more rounded. And let's see what other alternatives we have than using continuous. Let's see what we have. We have also circular. So yes, a circular, it's, well, it's not continuous. If you want, so you can see visually, you can see like, basically this is like the border of a circle, I guess. And when you do continuous, it's not the case. Yeah, like at the beginning, it picks up more slowly. If you're interested, you can have a look like on Wikipedia. The difference between it's like it's defined mathematically, and it's like one of the two can be differentiated and the other one cannot. It's kind of interesting to see, but way too complex for me to like improvise an explanation of how it works right now. Okay, you were saying line 25, there is the padding. So let's see, like for instance, if I comment this padding, what does it do? Okay, so this is the padding that gives the space around the text of the caption and that gives it space to have the background around it. And then we have the other padding right here, and this is the padding that gives the space at the bottom. So by default, overlay bottom would have aligned the bottom edge, but this extra padding right here makes it that we have, as the name suggests, an extra padding. What's interesting to see is that the order of modifiers is important because, as you can see, I have the text. Then around the text, I add a padding. Then I say I want to color that padding with the background modifier. And then I want to add some extra padding that will not be colored because it is applied after the background modifier. So that's one of the very important things to keep in mind when using SwiftUI, which is that the order of modifiers matters and matters a lot. And so, yeah, maybe line 25. Oh, yes. So you had the correct line. Well done. Okay, so let's get back. So now they say that this padding puts some space between all four edges of the photo and its containing view. So it's the white space we see around the image, okay? And if we delete the padding, we can see how that changes the layout. The padding modifier also appears twice in the caption view. Remove each of those as well to see how their absence affects the layout. So we've done the second part of the experiment. Let's see if I remove that one. And I guess it will be better, like, even though I prefer dark mode. I'm going to put it back in light mode just so that we can see the padding better. And when I comment it, you can see that this time it touches both edges of the screen. Okay, going to uncomment it. I'm going to go back to dark mode super fast. All right. Okay, next is section 2. So defining a background. So the overlay modifier on the caption photo contains a caption view to display the caption text. Okay, that's what was implemented in the code we looked at before. The caption view uses the background modifier to place a shape behind the text that partially obscures any content behind it. So that's translucent white right here. In this example, the photo is behind that text. So, and it provides higher contrast for the text because without it, if I go back to Xcode, as you can see, the text would be much less legible. Let me comment it. Okay, I need to comment both lines. Okay, and indeed, the text is not legible at all. All right, let's get back to the tutorial. So here they're talking about the padding modifiers we had a look at. So this first padding modifier adds some space between the words and the edges of the contrasting background underneath. The structure of the code matches the visual appearance of the view, meaning that the padding is between the text and the background. And they say it's important, that's what I was saying before, choose carefully how to combine padding with an overlay or background modifier. If you pad the primary view before modifying it with the overlay or background, the system uses the size of the padded primary view to calculate the placement of the secondary view. Apply the padding after the overlay or background to put a little space around the views that includes both layers. Let me read that again for the second sentence. So, if you pad the primary view before modifying it, okay. Yes, so if you apply the padding before the background modifier, the background will apply to the extra space given by the padding. That's what we've seen. And if we apply the padding after the overlay, it will put extra space, but will not be colored by whatever the background colored it with. And so you're saying, Wilfried, you thought that overlay and background was synthetic sugar when compared to this tag? Apparently not. Yes, and to be honest, I was not aware of that difference. So actually, like, it goes to show like how well made that tutorial actually is, because it gives some very good and very valuable information. And I guess this tutorial is also quite new, because since it uses Xcode 14, it must have been released like around or slightly after the WWDC, so like 2 months ago now. So next we have the modifier background. So a background modifier like the one we use is similar to an overlay modifier in that its content bases its size on the size of the view it modifies. However, a background modifier puts its content behind the view it modifies rather than in front, but the name already suggested it quite strongly. To provide a high contrast, whether or not people use dark mode, this background modifier uses a custom color with partial opacity. So it's called text contrast. And so the text contrast color set in this project's asset catalog defines separate color value for light and dark appearances. Let's have a look at them. So I need to open that panel. Let's go into assets. So here we have the text contrast, and we can see that when we are in light mode, it will be white, and when we are in dark mode, it will be dark. And the idea is that the text primary color works the other way around, so it's going to provide a color that will contrast against the text primary color. All right. Then we have a rounded rectangle as a shape which accepts whatever size its containing view proposes. So a shape is what I called earlier a filling view, meaning it will take as much space as is available. And in this case, the background modifier creates that containing view, and any background modifier determines its size from the view it modifies, meaning that the rounded rectangle will take the size of the view on which we have applied the background modifier, and so that size is the text plus its padding. So in this case, I'm sure I'm just going to read what I've explained, but let's go ahead. In this case, the background modifier creates a containing view, and any background modifier determines its size from the view it modifies. This results in a rounded rectangle that is the same size as the padding around the text view. Once again, I got ahead of the tutorial. This additional padding around the background adds space between the outside of the caption view and the container it appears inside. In this case, caption photo is the containing view, and so this is why the rounded rectangle does not touch joins. I don't know what is the exact term, but it does not touch the bottom edge of the image. That because of this extra padding, and so we can see it at the bottom, but of course it's also there on the trailing top and leading edges. Okay, since we're done with this section. All right, we are still in the second chapter. This is taking a little bit more time than what I expected, but on the other hand, we have a lot of high quality information, so that's pretty cool. I'm also learning stuff, so I'm pretty happy with that choice of tutorial. So now we're going to learn how to choose the right way to hide a view. So control whether a view exists and how that affects the overall layout. If your design has views that aren't always relevant, you have a choice about how their absence affects the overall layout. You can lay out all the other content as if the view doesn't exist, then update the position of the other content when the view becomes visible, or you can reserve space for the view regardless of whether it's visible, so that when it becomes visible, none of the other content needs to move to accommodate it. They raise some very good points here. And so we need to download the projects file. So just like before, I'm going to go in Xcode. I'm going to close the one that was already open. Okay. I'm going to open the other one. And I need to make the view the window the right size so that you can see it correctly in the stream. That's perfect. Okay, let's get back to the tutorial. So first section is conditionally removing a view. So your design might have a login screen. Doesn't show. Okay. There are definitely some typos in that tutorial. Your design might have a loading screen that doesn't show an error message the first time it appears, but adds an error message after someone mistypes their password. That reminds me of what we have implemented in the previous live about discovering async algorithms. The username or password field shouldn't shift position depending on whether the error message is visible, because that would be a bit weird for the user. So we want to use an opacity modifier with a value of 0, so that the layout accounts for the error message whether or not it's visible. So it's there in the layout, but it could be hidden by setting its opacity to 0, which means it's totally transparent. You can also use this strategy for removing a view that doesn't affect other views placement, like a view inside an overlay modifier, for instance. Or an order form could display a second set of address fields if a person chooses not to use the same address for their shipping and billing addresses. Once again, a very common use case. For content like address fields that people might need to scroll past, use if, so the if control structure, to only make room for the content when it's visible and shift other content as it appears and disappears. If you need to reserve space in a layout based on the measurement of a view, but never want to show that view, you can use the hidden modifier. Okay, so we're starting to see a few strategies. So set the opacity to 0, use an if, or use the modifier hidden. A voiceover and gesture recognizer also ignore a view that you remove in any of these ways. So all these views are hidden. The only difference is whether or not it affects the layout. It's whether or not they affect the layout, the only difference is whether or not they affect the layout of the view while they are hidden. That's what I wanted to say. So to show the difference between these approaches, this example uses a sequence of train cars. Each train has 3 views, a front, middle, and rear section, and uses the train car symbols from SF symbols. For a long train, the front, middle, and rear car all appear. For a shorter train, the middle car doesn't appear. The code that defines each train uses a different technique to omit the middle car. So it's kind of a nice way to show it with a code that stays simple. So it introduces some notion of state. So the state property wrapper, not just property, so the add state right here. So the state property wrapper tracks whether to show or hide the middle train car. In a full app, the data determining whether to hide a view might be an environment value or a parameter of a view that contains the view you want to hide. So what you should remember is that there are other ways to manage a data flow than the add state modifier. But the add state modifier is the most simple way to manage data changing over time. If the first train uses if, a conditional clause to control the middle car. So we can see that in the H stack, we have the two images for the rear and the front, and then there is a if to display or not the middle car. Okay. When a longer train is true, and we can see that longer train is controlled by this on-off switch right here. So when longer train is true, the middle car is part of the train. When longer train is false, the middle car doesn't exist, and the other cars are close together. So as we can see right here. You can also use an else clause the same way. The content of the else clause only exists when the condition is false. So let's go inside Xcode. So it's this view right here. So I definitely want to set an iPhone. Now it should work. I mean, it worked last time, so there is no reason for it not to work. Perfect. Let me just go dark mode. And so we can see that with the code that uses an if statement, so that code right here, when the train isn't there, basically there is no space reserved for it because that image is just not part of the view hierarchy, we could say, when the boolean is set to false. Okay. The second train uses the opacity modifier to control the visibility of the middle car. So when longer train is true, the middle car is part of the train and it looks just like the previous conditional example, but when longer train is false, the middle car still takes up space in this train. And so they say use an opacity modifier when you don't want other content to shift around as the view appears or disappears. This modifier is similar to the hidden property in UIKit, which I'm sure you're very familiar with if you have ever used UIKit. And so here it's this code right here. So the code that uses opacity. And you can see that indeed, whether longer train is set to true or false, there is always the same amount of space taken by the image. Only the image won't appear because its opacity will be set to 0 when the boolean is set to false. All right. And the final train uses the hidden modifier to control the middle car. Notice that toggling the longer train control doesn't affect the middle car of this train. It's never visible, but like the opacity example, it still takes up space. So hidden, it seems that there is no argument on it. So a hidden view can be useful in some rare situations where you want to use the size of the view to affect layout even though you never show the view. So kind of like if you're using the size of a view, if you have a view and you use it to size another view, basically. There is a warning. Let's see what the warning is. You could define a view in both an if clause and its corresponding else clause, adding a hidden modifier to one, and get a layout like the opacity layer. So I could do, yes, if longer train image and else the same image, but with the hidden modifier. However, SwiftUI doesn't consider that the views in the if and else clause as the same view because they are defined separately in the structure of the containing view. This may interfere with animations transitioning between them. For more information about the structural identity view of views in SwiftUI, watch Demystify SwiftUI. So a few things to say here. So first thing is that if you ever see a modifier called apply if, basically it has the same drawback than what is said in the warning, meaning that both the views in the if and the else clause will be totally different in the eyes of SwiftUI, and so SwiftUI won't animate from one to the other. That talk from the WWDC from last year is really great. And also, there is a great article on obj.io on why modifiers like apply if are not that great in most situations. And it's very good to see that they've made that warning explicit in a learn from the basics tutorial. Okay, we are done with this section. The next one is about organizing and aligning content with stacks. It's the last one of that chapter. So create dynamic alignments that adapt to data and environment changes using stacks. When you have information to communicate that draws from a changeable data source that includes text and images, it's important to align the content in a way that can adapt. This tutorial walks through using stacks to align content in rows and columns. It also uses stacks to create graphic elements that help organize information. Okay, and we need to download the code to experiment with it. So that's what I'm gonna do. I'm also going to open it. Before I do, I'm going to close the project I had open before. All right. And just making the window the correct size. Perfect. Let me get back to the tutorial. So section 1, manage related data with a view model. That's interesting. Apple mentioning a view model and so taking a stand on which architecture is good for SwiftUI is quite new. Actually, I didn't expect this tutorial to mention something like a view model. Let's see how it goes. So the first step in defining a view is to identify the data that the view displays. This view layout displays the details of an upcoming event. So we can see it actually right here. Let me scroll up a little bit. So it's this view right here, including the event's name, date, and location. It also includes an icon indicating the type of event. To organize that related data into a view model, this sample defines a custom structure. And so you are saying, Wilfried, I know it is subject to debate and not a basic topic, but I never use as at state as I apply MVVM design pattern quite strongly. I wrap the state into state objects together with add published props. So you're right that it's quite up to debate, especially like during the last days, I saw some debate on Twitter on whether it was a good thing to introduce view models or not. But I think, yeah, I tend to agree with you, and I tend to only use add state for what we could call like the transient state of a view, like for instance, selected index, that kind of thing. But for the rest, I do create view models that conform to observable objects. One thing to note though is that add state is quite good when you want to just prototype something quickly, and then if it works as you expect, only at that moment do you make it, do you like move it into a fully fledged view model. Okay, let's get back to the tutorial. So this event struct defines all the data for the event. The date is a date value rather than a formatted string, so the view can specify the date format. The symbol property is the name of an SF symbol for the event tile to display. Okay. The event tile gets all the data for a specific instance from the event structure in the tile's event property. Hey Chris, nice to see you here. Okay, so let's see. We have the event right here. Note that the event is a constant, so the view won't react to it changing because it simply cannot change. It's a constant. And so 3 different parts of the event tile view need to use the height of the top stripe, so it's also a property outside of the body. So stripe height, what is it exactly? I guess it's that thing right here. So this little line that is from a clearer blue than the rest. We'll see if I'm correct. This is the only constant that specifies a dimension in this layout. All the other dimensions of this view depend on the data in the event and semantic values in modifiers such as font. Okay. The idea being to have as little hard-coded values as we can, because hard-coded values, of course, they kind of go against having a layout that adapts to the context. All right. Defining a view with nested stacks. So after you define a data model, you can create views to display the data and organize those views with stacks and alignments. A V stack arranges the text in a column, and an H stack aligns the icon with the title next. So we've seen how V stack and H stack work, but notice, for instance, that here, the two H stacks, you see, is it like two V stacks, or is it an H stack but an alignment that aligns it with the second element of the V stack at the top? I guess it's two V stacks because it's much simpler to implement, but you can implement both in SwiftUI. So let's see. Step 1, so the leading alignment on the VStack overrides the stack default center argument. So you can see this time we are providing an argument to the init of the VStack. I mean, we were already providing an argument because there was the closure with the content of the VStack, but this time we provide another argument supplementary to that closure, and so is the alignment argument, which has a default value of center, but here we say we want a leading alignment. So as you can see, all the texts are aligned on the leading edges. And actually, let me go into Xcode to see like if I can change the alignment to show you how it would look, because it's always like you learn better when you see it, basically. Okay, so it's this VStack here, so it has a leading alignment. First, you know what I want to do? I want to put it in dark mode, much better. And so if I do no argument, so you see it's center by default, and I can do leading, and I can also do trailing like that. So this is how the alignment argument works. Let me put things like they were. Okay, and back to the tutorial. Then the text initializer. So this time we use a different initializer for text, because we give it both a date and a format. And so this initializer automatically accounts for environment specific conditions like the current calendar and local. So we give it the date as the first argument, and then for the format, so it's the new API to create formatters in an easier way than just instantiating and configuring an NS date formatter. So you do date.format style, and then you have kind of like a builder syntax where you say, okay, I want to show the day with the default amount of digits. So I guess that's why we don't have a leading 0 in that case. And then the month with a Y display. So I guess also why June is spelled out with all of its letters and not just like GUN and then a dot, for instance. It's kind of similar in like API design to what there was in Swift charts, which we've used in a previous video like 2 or 3 weeks ago, if I remember it correctly. Okay, then the title font makes the title text and the gift image more prominent than any content in the default body font. So both the image and the text have their font set to title. You can see that this time it couldn't have been factored out because there is no common ancestor that contains the two and only the two. So the font has to be set explicitly on each of them. All right. The precise font size and weight depend on the environment, including the user's current dynamic type settings. So by environment, I guess it will also depend, like maybe on iOS, text would be like a little bit bigger than on macOS or the other way around, that kind of thing. And so for the experiment, they suggest we customize this symbol with the techniques in configuring. So for instance, there was something about colors. You remember, I could call a modifier on an image that was an SF symbol, and it would do something with colors. Is it like... No, it's not that. Damn it. I don't remember. But maybe I have to do it before the font, actually. Like if I do color like that. No. There was something, maybe it was like rendering. Was it symbol rendering mode multicolor? That was that one. Okay, so here it's red. And what do we have else? We have something called palette also. Okay, that one does nothing. What does it do? Oh, okay, because then you can like provide like more than one color. So if then I do, for instance, foreground color, and I give 2 colors, so for instance, red and blue. Okay, I guess there is only one layer in that very simple symbol. I will let the code like that, and we'll see like later on if we have the chance to see a different icon. Okay, then the first text baseline alignment in the H tag aligns the gift image with the title text. Okay, so it's right here. if you're arranging text and a symbol that only needs to align with each other, it's better to use a label. Label aligns its icon to the first baseline of its title by default and adapts to the context in which it appears. Let's see what happens if I don't provide this alignment to see. Oula, I don't want to get rid of the h tag. Okay, so it would be centered with the entire content of the vstack that is right here. But when I say alignment first text baseline, it aligns the icon with the baseline with the first baseline inside the vstack, which is the one of that first label. And I think we also have last text baseline, which does the same thing, but for the last text baseline. And if you don't know what the baseline is, it's the imaginary, so it's something that comes from typography, and it's the imaginary line on which the characters are, we could say, placed. And so, for instance, the bottom of the Y is a little bit below the baseline. And so you're seeing, Wilfried, that's the part which you dislike putting in the views, as you really wonder how you could put unit test, or you could unit test this formatting. Or let's say you change your mind and want to implement it using using UI kit you cannot reuse. So for the testing part, I would suggest an approach like snapshot testing, honestly. There is a library made by the guys at Point 3 that works pretty well. But yeah, I guess that... you're saying for the text formatting, it's true that yes, you're right. It's hard to test it. The best you could do is to have constants inside your app that holds that value here that is highlighted, that hold the format, and make sure in your test that the constant indeed yield the correct string, that kind of thing. But I agree that when it comes to testing, it's not the easiest one to test. And there are also apps where it's super important to test very thoroughly, like the dates that are being displayed. For instance, I worked on banking apps for a long time, and it's very important you don't show like wrong dates, because dates are connected with money and whether like you owe money to the bank, for instance. So you want to make sure that you display the correct dates. So that's a very good point. Let's go back to the tutorial. So now they say adding a background with layered shapes. So to indicate that all of this information represents a single event, a background modifier contains this stack of shape views. This defines a background that adapts to the size of the information the main view displays. So I guess it's the background with the line that is a bit more bright than the rest. Okay, so how is it implemented? So first, to make the background bigger than the h tag that encloses all the content, a padding modifier is applied. And we've already seen this technique being applied before. Right, we've seen it when with the caption that was displayed as an overlay of the image. The second use of the same padding modifier on the main content adds space for the stripe at the top of the view, in addition to the space defined by the previous padding modifier. So this time, it only adds space at the top edge and with the height that is stored inside the constant stripe height. Then the background modifier bases its size on the size of the view it modifies and puts its content behind that view, meaning that the size is both the size of the h tag plus that padding plus that second padding. Okay. This top align vstack layers the brighter stripe rectangle over the rectangle that fills the background of the event tile. So here we are combining both the background modifier and also a vstack. So things are getting a little bit more complex here. So we have the background, which is going to display a background that will not be able to go over the size of the view that it is called on. And then we have a vstack in which there is a rectangle with an opacity of 30% and another rectangle on top with a frame that gives it a max height of the height of the stripe that we have defined. And finally, they are stacked with an alignment top, meaning that one will indeed go over the other, but they will align on the top edge. Okay. And the foreground color is teal, as we could have guessed from the preview. All right. Let's see if there is something else before I go back to Xcode to experiment with this. Okay. And so here the frame modifier specifies the height of the stripe, leaving its width dependent on its containing view. So we only provide a max height for the vertical dimension. For the horizontal dimension, the rectangle will take as much space as possible, because remember, shapes take as much space as they are given. But as we've just seen, we can constrain one of the dimension of the size without constraining the other. Specifying a frame on a decorative shape like this stripe is a common pattern. Note, specifying frames on text and controls may interfere with the sizing behavior and usability of those views. To learn best practices for maintaining the size of various views, see maintaining the adaptable sizes of built-in views. So we've seen it before, but basically the idea is that if you make a control too small, user won't be able to interact with it or see it, that kind of thing. Let me just go back to Xcode and just to show you what's interesting is that for both HStack and VStack, there are only 3 alignments: leading, center. VStack has leading, center, and trailing. HStack has top, center, and bottom, and also the one about the baseline. But this stack has many more because it has all the combinations. It has trailing, bottom, bottom leading, bottom trailing, center, center first text baseline, leading, leading first text baseline. Basically, like there is the entire Cartesian product of the 3 of them. So there should be like 9. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So 16. So it's not 3 times 3 times 3. Maybe I got it wrong. I don't know. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So yeah, there are 15 or 16, one of them. So I got my, I guess I counted some of them twice. But the thing is that there are lots of them. So here it was doing a top alignment, but we could also do like bottom. So it would put it at the bottom. We could also do like top leading. So here it wouldn't change anything. But if I also gave it a max width of like 20, for instance, is it going to work or not? Oh, I think I got, yes, the width goes before the height. So need to do it like this. You can see that this time top leading is not the same as top and is not the same as top trailing. So we have many more possibilities when using a Z-stack. And so for instance, if you wanted to display a little badge at the top leading corner of a view, this is what you would be using. Okay, let me put the code back to how it was before I started messing with it. And let me get back to the tutorial. So here, applying the teal foreground color modifier to the stack specifies the color for both the rectangle views in the stack because the modifier has been factored out. All right. And finally, clipping the final view with the clip shape and the rounded rectangle shape applies the rounded corners only to the outermost edges rather than rounding the corners of each views. So this one, both these modifiers are factored out, but the difference is that this one is factored out and it's then, we could say, distributed over each of the inner views. The clip shape is not the same thing. The clip shape is consumed, we could say, by the edge stack. And this avoids rounding the bottom corner of the stripe rectangle because indeed, let me go back to Xcode. We don't want these two corners, so top, bottom leading and bottom trailing, to be rounded. Otherwise, it wouldn't look very good. All right, are we at the end? Yes, we are at the end, and we can start the last chapter, which is driving changes in your UI with state and bindings. We are getting, I was about to say we're getting into the serious stuff, but all the thing we've seen was quite serious stuff. And for a basics tutorial, actually, it's not your like 30 minutes tutorial where you like do one or two cool things and then haven't learned that much. Here, I think once you're done with it, you have like some good knowledge of how SwiftUI works. I'm thinking like I was giving training sessions of SwiftUI earlier this year, and yeah, I guess this is covering what I was doing during like the first like 3 or 4 hours. So that's some very good content. So indicate data dependencies in a view using state and share those dependencies with other views using bindings. The user interface of a SwiftUI app is a composition of views that form a view hierarchy. We've seen that now. Each view has a dependency on some data. As that data changes, either due to external events or because of actions taken by a person using the app, we could argue that actions taken by a person using the app are also external events. SwiftUI automatically updates the view to reflect those changes. This sample shows examples of using state variables to indicate data dependencies and sharing data with other views using the binding property wrapper. Okay, so you know how it goes. I download the code. So this one, I close the one that was previously open and I open the new one. And yeah, I agree with you, Wilfried, like while I resize the view that the code that was displayed in the previous example was very big and it could have been broken up. And as you're saying, using compute property is a very good way to break properties easily because you're still inside the same type, so you still have access to the exact same variables, but while still maintaining some like separation and making it easier to be read. Or at the very least, add some comments, like to say some mark comments, / mark, so that it appears in the minimap and it also gives like an outline of what is implemented inside the body. Like rule of thumb, I would say when you're starting to go above 4 levels of nesting inside the body, it might be like a good sign that you should start breaking things up together a little bit. And yeah, definitely, like I had already done like some of Apple's previous tutorials on SwiftUI, and I found they were of very good quality. And this one, yeah, is definitely very, very, very good quality. I'm super glad I picked it to do this live because all the information that's being displayed, I 100% agree with it. And I think, yeah, it's being taught and introduced in a very good manner. So first we learn how to separate properties and imperative code from the view. When a view needs to manage more than a single piece of state data, it can be helpful to manage that data in a separate view-specific structure. Are we talking about a view model? This approach helps make the declarative interface code of a view more readable by moving properties and imperative code outside the view. It also helps us make unit testing state changes easier to implement. This is what is also referred to as keeping the view as dumb as possible, which means that there shouldn't be any business logic inside your view. Your view should be dumb. It should only display data that has been already prepared for it. This sample app displays a collection of cooking recipes. A person using the app can view the details of a recipe and add new ones. To add a recipe, the sample presents the custom view recipe editor, which needs 3 pieces of state data: a recipe, a flag indicating whether to save the changes, and a flag indicating whether to present the recipe editor view. The sample app separates its state data and imperative code from recipe editor by defining a recipe editor config struct. That's interesting. So they're using a struct as some kind of a view model, which is interesting because before they were pushing using observable object. So let's see where this goes. So we have a struct called recipe editor config. So it's a struct. It's not a class. It's a value type, and that's something that's very important to keep in mind. That stores the state data that the recipe editor view needs. To trigger state changes that happen in the recipe editor view, recipe editor config provides mutating functions that update the data to reflect a new state. So the method present add recipe sidebar item changes the state of the view to indicate that it is editing a new recipe. The app calls this method when a person taps the add recipe button. So this is definitely a view model, except that it's implemented not using observable object, but rather using a struct and mutating functions, which is quite an interesting strategy. All right. So this method creates an empty recipe as the recipe to edit, and you can see that it's basically setting this empty recipe to the recipe property. So that could have already been holding changes made previously by the user. And the static method empty recipe creates a new instance of recipe setting its properties to the default values of a new recipe. So it's kind of like a factory method, we could say. In addition to the default values that empty recipe sets, present add recipe sidebar item, so the method we're in, sets the recipe's isFavorite and collections properties based on the selected sidebar item. You know what? Maybe I should open the app to see what it looks like. Maybe this will help. Okay. Let me launch the app because I have a bit of a hard time understanding what are these sidebar items. Okay, apparently this app is not meant for iOS. I guess it's meant for iPad. Let's go with an iPad mini, so that it doesn't take too much space. No? Is it a macOS app? That's weird that it's not available in iOS. Okay. I will refrain from launching the app. Just take a look at the code in the web page. So we are switching on the sidebar item, and if we are in the favorites, then the new recipe is a favorite straight from the start. If we are in a collection, that recipe is part of the collection. Okay, so it's basically an app to manage recipes, and yeah, depending on where you are in the interface, you want to set some default properties for the new recipe. That makes total sense. Okay. So by setting the isFavorite and collection property, the new recipe automatically appears in the appropriate list of recipes after saving the recipe. So this is something that you would expect from the UI of an app. It makes total sense. The method also sets the should save changes flag to false because the person using the app hasn't indicated they want to save the changes yet. Okay, so there could have been a different value before. That's why it's set back to false. And then this method set the isPrinted flag to true to tell SwiftUI to display the editor view. So I guess it displays some kind of like a model to edit a recipe. Keep reading to learn how the recipe editor appears based on the isPresented value. All right. So the method present edit recipe is similar to present add recipe, but for editing an existing recipe. So yeah, it's the pattern of like you can add a new item using a model, and I guess you can edit also using a model this time. It's not just pushing in that case. The recipe editor config supports two other mutating methods that trigger state changes in the editor while also separating imperative code from declarative interface code, down and cancel. So just to see what was inside present edit recipe before. So yeah, it is given a recipe that was previously created. So it puts we could say it's the current recipe to be the recipe to edit, and then should save changes to false and is printed back to true. Okay. Then inside done, so the done method indicates that the editor should save changes made to the recipe and dismiss the recipe editor view. So it sets two booleans to true. Okay. If you never use SwiftUI, this might look a little bit weird that we are setting booleans to show and display a model, but when you will see how a model is implemented in SwiftUI, you will see that it makes total sense. So this method sets should save changes to true to indicate that the app should save changes made to the recipe. It also sets isPresented to false, which tells SwiftUI to dismiss the editor view. And finally, the method cancel is similar to done, but it sets should save changes to false, telling the app to disregard the changes made to the recipe. The method also sets isPrinted to false, which tells SwiftUI to dismiss the editor view. So what's interesting is to see how both these booleans will be observed by the view. And I guess we get to it. So binding the view to its state data with a structure in place that contains the data that the recipe editor needs, and method that change the state of the editor, look at the recipe editor view to see how it uses recipe editor config. So recipe editor is a struct that conforms to the view protocol. So it's a view that will be displayed on the screen. The struct declares the binding variable config of type recipe editor config. So recipe editor config is the code we've just seen before, what seems to be the view model for this view, which contains the state data the view uses to determine its appearance. And also it contains both the state data and also the logic to transition between states. The binding property wrapper provides a two-way read-write binding to data that the view needs. However, recipe editor doesn't own the data. Instead, another view creates and owns the instance of recipe editor config that recipe editor binds to and uses. So that's the difference between add state, for instance, and add binding, is that when you use add state, you own the data. That's why it's a good practice to always set an state property to be private. But on the other hand, when you have a binding, you can read and write to it, so two-way binding, but you don't own it. Someone higher on the view hierarchy owns it and has passed it to a view that is on the lower part of the view hierarchy. So from a parent view to a child view. So it's a top-down data flow, we could say. So recipe editor contains a recipe editor form which displays the input fields needed to edit recipe data. Recipe editor passes the binding variable config to recipe editor form. It passes the variable as a binding indicated by prefixing the variable name config with the dollar symbol. Because recipe editor form receives config as a binding, the form can read and write data to config. So config has been annotated with the property wrapper. Config has been annotated with the property wrapper at binding, and so when we use config, we just interact with the wrap value, which is of type recipe editor config. But if we want to pass the binding to a view that is even more in a lower level of the view hierarchy, we need to pass the binding, and to access the binding, we use the dollar character as a prefix. And if you know property wrapper, you probably know that this dollar character, actually, it calls the projected value of the property wrapper. And in the case of binding, the projected value is just self, so it returns the binding. And this way, you can have the same data go through several layers of your view hierarchy, and each layer is able to both read and write to that data. And at the top, there is someone that owns that data, and I guess we will see who it is, which view it is, a little bit later in the tutorial. Okay. The editor also displays a cancel button in its toolbar. So there is a toolbar item that is cancel, so displayed at the top left of the model. And so when we click on cancel, we do config.cancel. And when the person taps the cancel button, its action calls the mutating method cancel defined in recipe editor config, which sets should save changes to false and is presented to false. Okay. The editor also displays a save button that when a person taps it, calls the mutating down method, which sets should save changes to true and is presented to false, telling the app to save any changes made to the view and dismiss the editor view. So cancel and save button, basically. Settings should save changes and is presented in the I guess it's setting, there is no S. Setting should save changes and is presented in the cancel and down methods make the view code easier to read because each button's action only needs one line of code. The button actions could have explicitly set config, save config, and config. No, it's config should save changes. Like here, the tutorial is getting tired, just like I am, I guess. It could have saved both. It could have set both Boolean flags, but keeping imperative code in action to a minimum helps make the declarative interface code of the view more readable and easier to maintain. And here, this recoup with what you said earlier, Wilfried, that we should keep the view as simple as possible. All right. And finally, creating a state variable in another view. So the recipe editor view has a binding to an instance of recipe editor config. We've just seen that. The editor can read and write the data, but it doesn't own the recipe data. Instead, the view content list view creates and owns the data, and SwiftUI manages the data for the lifespan of the content list view. So we have this content list view. Okay, let's see. So it's another view that conforms to the view protocol, and it displays this list of recipes. And we can see like there's an image, there is a title, a subtitle, there is whether or not it is a favorite, and then there is the plus button, I guess, to add a new recipe. Okay. So content list view is also responsible for displaying the recipe editor when a person wants to add a recipe, making this view the ideal place to create an instance of recipe editor config. So the view defines the private state variable recipe editor config of type recipe editor config. So right here. I was about to make a comment about add state, but I know how it goes. I make the comment and then I see exactly what was written here. So I'm just going to read what's there. So the recipe editor config declaration includes the attribute for the state property wrapper. So this add state annotation right here, which tells SwiftUI to create and manage the instance of recipe editor config. I don't really like the fact they use the word instance for a value type because it doesn't have an instance really. So like that choice of word could be a bit confusing. There are values, and whenever we use the mutating function, it creates a new value. And it's true that addState manages an instance that is a wrapper around the current config, but the choice of using instance here, I think, is a bit confusing. And you are seeing Wilfried. If a view model is provided to another struct as a sub-view model, then you need binding to a view model which make it dependent on SwiftUI, which you think is bad. That's true. That's true that with this strategy, SwiftUI, and so the UI framework, owns the parent to children relation in the data flow. That's a very good point. Indeed, if you want to make sure, for instance, that the method is called correctly, that kind of thing, it could be harder. Yeah, thank you. That's a very good remark. Let's see where I was. I was here, I think. Okay, each time view state changes, that is, data that recipe editor config contains changes, SwiftUI reinitializes the view, reconnects the recipe editor config instance to the view, and rebuilds the view defined in the complete body property, which reflects the current state of the data. For more information, see state and data flow. So what you should take away from this is that basically, whenever the content of an state property changes, the body is computed once more, and SwiftUI will render any difference between the new and previous values of the body. We see also something called @environment object here, but we will see later how it will be used. But here, yeah, I think I see the pattern where we have like observable object for all the recipes, so for all the data, and for what is currently being displayed in the view to use like this recipe editor config. They're kind of using it for like transient state of the view, which is kind of what I was hinting at a bit earlier. So interesting pattern that is actually more complex than what I thought. And once again, shows that this tutorial goes a bit into like questions of architecture, which was not the case from Apple's tutorial lately. So it's nice to see that they are taking a stand at making suggestions on how to architecture an iOS app. So this view also displays an add recipe button in its toolbar, so the little plus icon. The add recipe button appears as a button with a plus sign as its label. Once again, exactly what I was saying. When a person taps the add recipe button, the button's action calls the mutating method present add recipe, which changes the data contained in recipe editor config. And so recall that present add recipe creates an empty recipe and sets its isFavorite and collections property values based on the current selected sidebar item. The method also sets should save changes to false and isPrinted to true. Keeping this imperative code outside the view helps make the declarative code of the view easier to understand and maintain. When present add recipe changes the data in recipe editor config, SwiftUI reinitializes the content list view instance and reconnects recipe editor config to the instance that it's managing. SwiftUI then rebuilds the view from its complete body so that the view reflects the current state of the data. Once again, the fact that they use the term instance for content list view, even though it's a struct, I'm not a big fan of that choice of a wording here. Okay, and so this is how the model is presented, so through that modifier called sheet. After calling present add recipe sidebar, the flag isPrinted is set to true, which tells SwiftUI to display a sheet that contains the recipe editor, so basically displaying a model. The Boolean value recipe editor config isPrinted determines whether to present the sheet that contains the recipe editor view. When the value changes from false to true, the sheet presents a model view containing recipe editor. When the value changes from true to false, the sheet dismisses the model view. And so the modifier sheet is presented on dismiss content, receives a binding as indicated by the $sign right here, so a binding to the Boolean. This binding lets the sheet read and write to the property. For instance, when a person dismisses a sheet by swiping it downward, the sheet sets recipe editor config isPrinted to false. This change causes SwiftUI to reinitialize and rebuild the view, and because isPresented is now false, the sheet no longer appears. So that's how you print a model in SwiftUI. You have a Boolean that is the source of truth of whether that model should be displayed, and then you use the modifier sheet, you give it a binding to the Boolean, you give it the content of the model, and optionally, you give it an onDismiss handler. What's interesting to note is that there is another version of the sheet modifier that takes not a boolean but an optional, and you can use it if you need some data to show inside the model. And just like the boolean, when it goes from false to true, it displays, just like with the boolean, when it goes from false to true, it displays the model. With the optional, when it goes from nil to some value, it displays the model, and when it goes back to nil, it hides the model. So the sheet contains recipe editor, a custom view that displays a form containing input fields that lets a person change data of a recipe. Recipe editor receives a binding to recipe editor config as indicated by the $sign prefix, which makes it possible for the editor to retrieve and make changes to data contained in recipe editor config. This includes changing recipe data and triggering state changes. All right. When the value of is presented changes from true to false, the sheet calls it on dismiss action, which calls the didDismiss editor method. The sheet also calls on dismiss when is presented changes from true to false in the cancel and done method that recipe editor defines. The sheet is able to detect the value change because it has a binding to the recipe editor config is presented property. So this works both from, like we would say, user generated dismisses and also programmatically generated dismisses. Okay. The view implements the didDismiss editor method, which saves the changes a person makes to the recipe if recipe editor config should save changes is true. Otherwise, the method disregards the changes. So when the view is dismissed, if that boolean was set true, then the recipe is saved. So this is how that boolean is taken into account. You can see that this one is not observed, we could say. They could have also used the value, the modifier on change of perform, but here using the onDismiss handler is even better because it makes it sure that we only run this code when the model is dismissed and not by accident when changing the value of the boolean in some not related code. What's interesting is that it doesn't set the boolean to false afterward. That's interesting. We'll see if there is a reason why for it. And there is a note, recipe editor config concerns itself with recipe editor and only that view, which is why contentless view implements the didDismiss editor method instead of recipe editor config. This approach keeps the area of concern separate, but still puts some business logic inside the view. So arguably, I might have wanted to put all that code right here, or at least that code here, inside the recipe box rather than inside the content list view. That's my personal choice, but I think it makes sense, especially if you want to test that code. Okay, we are getting closer to it. We only have 2 chapters, and yeah, we've done 2 hours. We're going to go like 2.5 hours. That's gonna be nice. I can tell you, like in Lyon, it's a bit hot. So like when it will be over and I can put the AC on, I will be a bit happy still. And you're saying they've removed and or deprecated the alert modifier in it working this way with functional item. You really like that way of working as there was only one source of truth. Quite disappointing. Oh, I did not know they had deprecated it. Let me see. Oh yes, but I cannot build the app, so it's not going to help a lot. But so where is the sheet modifier? So it would be in views, in content list views, I guess. Where was it? Okay, it was that one. So there is this one. So the one with the item is still there. The one called action sheet has been indeed deprecated, but it's just a renaming, if I remember it correctly. And so you're saying the one for the alert. So there is alert is presented. Oh yes, alert with an item has indeed been deprecated. That's interesting. I'm wondering what the logic could be behind it. Maybe people like were doing too complex things, and because when you think about it, yeah, I mean, in an alert you always want to show some title. So I guess, but it's true that having an optional string would have been like better. Maybe like this was too generic and people would put like crazy objects inside of them, but maybe they should have kept one that would have had like a string. And I mean, anyway, you can always like make make your own quite easily. That's the nice thing with Swift supporting extensions. All right, so we are at the penultimate chapter, creating a custom input control that binds to a value. So we will learn how to provide interactions that are unique to our app with custom controls that bind to a value. SwiftUI provides input controls like slider, text field, and many other that binds I'm going to redo it. SwiftUI provides input controls like slider, text field, and many others that bind to a value and can change the value as persons interacts with the control. But every app is different. You may find that you need a custom control that provides behavior unique to your app. SwiftUI provides the building blocks you need to create a custom input control for your app. This tutorial walks through an example of one such control, a writing control. So to give, I guess, once again, this is exactly what is the next sentence. The sample app uses this control to let people write recipes from 1 to 5 stars. So you know the drill. I download the sample code. I close the current Xcode. I open the new one in the correct version of Xcode. All right. Now let's hope this time we can build this app for iOS. You know what? Let's check immediately so that we don't lose time later on if we can't. Let's see if it's still this recipe app. I'm a bit, yeah, damn it, we still can do it. Okay, it's a good thing the tutorial is very well made and we don't really need Xcode to follow it. So design a custom control. Before implementing a custom control, ask yourself what data does the control need and what does it do with that data and how it does and how does it represent the data visually within the app. There are also typos in the text, definitely. There are many of them. The sample app, for instance, needs an int property that represents the writing of a recipe. The control needs to be able to change the value of this property. And because the control shows the writing of a recipe, it needs to display a set of stars that reflects the writing value. For instance, the control star displays 5 stars when the writing value is 5. And actually, I think in my training session, I made people implement a writing, but it was not a custom control. It was just like to display the writing as a read-only value. So I think that's a very good example, and I might update the training session accordingly. So let's see. This sample defines the custom control as a structure named star rating, which conforms to view. Okay. And it has to conform to view because it appears as part of the app's user interface. What's interesting is that in UIKit, so of course this would be a UI view, but more specifically it would be a UI control to say that it is indeed a control. So we will see if there is a similar way to let SwiftUI know that we are defining a control or if there is no need for it actually. So let's see. The structure defines a binding variable named writing, which stores the writing of a recipe. By defining writing as the binding variable, star rating can read and write the value even though another view is responsible for creating the value. And this pattern is super common whenever you use either like a built-in control or create yours, you always pass it a binding basically, whether it's a stepper, a text field, a picker, or whatever, there is always an external variable that will be set by that control. And there could be external private add state inside the control, but there will, I guess, almost always be a binding provided by the view that uses the control. I'm saying one, but that could be actually more than one. It could also make sense like to have more than one binding. Maybe in that case, you could do like a tuple, but there will be, I guess, always one binding. I have a hard time imagining a control that doesn't have a binding. Even we've seen like showing a model, there is a Boolean, which is like the most basic 1 bit of data, but there is still that is needed. Then there is a private constant, max writing, that stores the highest writing possible the person can give to a recipe. And then, like other SwiftUI views, star writing implements the required complete property body. So all of the views in SwiftUI must implement a body. Must they all do it? Not really. If you want, after this live, take a look at, for instance, the public API of like text or image and take a look at what is the type of the body. And it should be interesting to see what it is. So then we have an H tag that displays the writing style in a horizontal line, which makes sense. And inside the H tag, we have a for each, so to be able to iterate over some data and provide a view for each iteration of the data structure. So we use for each to display the number of stars. For each iterates through a collection of data defined as a range of int instances. No, I would rather they say int value, because seeing an instance of an int, here I can definitely say this is incorrect and they should call it a value and not an instance. But the thing is that from 1 to 5, it's going to iterate through the integers from 1 through 5. And what's interesting is that I think you can only pass in like open ranges, so you have to do this +1 thing, and you cannot do like the 3 dots. I think it's not supported by SwiftUI. To be honest, I don't know why. I don't know if there is a strong reason for it. Maybe I should look for it. Maybe it's an interesting one. Important, the ID parameter is of type ID, which is hashable. The for each structure uses this parameter to identify the data, that is the integer values 1 through 5. The parameter value is the identity key path \self, which specifies an int instance for each integer. Because int is hashable, using this key path satisfies the requirement of the for each initializer method init ID content. And because the data is an increasing range of integers that will never have duplicate values, it's okay to use each integer value as its identifier. So why does SwiftUI need an ID? Is basically to be able to animate changes within the list. Like for instance, if an item changes position within the array, or is added or is removed, SwiftUI need to have an ID that it can use to do a diffing between the previous value of the array and the new value of the array. And here we're just using the integer itself as the ID, and it makes sense because since there are only integer in strictly increasing order, there will never be 2 duplicate integers. But of course, if you provide duplicate IDs, I guess you are in for a crash of your app, because SwiftUI cannot know what to do. It doesn't know what to display. It's kind of a fatal error. So what do we do inside the for each? So inside the for each, we pass a closure, kind of like we do for vtag and htag, but this time the closure has an argument called a value. And so we display an image, so system name star. So we use once again SF symbol. What's interesting is that depending on the rating, we will display it either filled or empty. So here you can see that the rating is only an integer, so there is no like 1.5 or 1.8 or 3.5 ratings, which would have required using something a bit more like complex, like showing a mask, for instance. Yeah, we could have done it with clip shape, but they chose a simpler approach. So what's happening? We do a symbol variant. It's interesting. So we have the symbol, and then we can do a variant. So either it's filled or it's just like just the outline. And this is going to depend on the value. So the control displays a filled star when the integer value is less than or equal to the rating value, and an empty star when the integer value is greater than the rating. So like if rating is 4, only the first 4 will be filled and the last one will be only the outline. If rating is 2, only the first 2 will be filled and the 3 others will be the outline. You get the ID. To determine which symbol variants to apply, fill or none, the control uses a ternary conditional operator. This operator takes 3 parts, which takes the form of question, or rather we could say Boolean expression, if true, if false. So it's an operator of Swift, but it's been there all the way back since the days of C and Objective-C. So I guess most of you are familiar with it. The control set the color of the star using the foreground color modifier. So like we've seen many times up until now. So up until now, we only have the part where we display, we could say, we've done the read-only part. Now we want the part where we can set a new rating. And so this is where it comes into play. You can see we're not using a button, we're using something a bit different. We're using this on-tap gesture, but it seems we have to wait a bit for the explanation. So now we want to make the control interactive. So star rating is able to display a set of stars to indicate the rating of a recipe. For instance, if the recipe's rating is 4, the control displays 4 filled stars, followed by 1 empty star. This is only read-only. To make start rating interactive, it uses the on-tap gesture action. Okay, let's see how it works. I'm going to get some water before. To make it possible for a person to interact with the writing control, star writing adds the on-tap gesture action, it's also a modifier, to each image created in the for each loop. That's interesting because in this scope, so that scope right here, we have access to the current value. So is it the first star, the second star, the third star, etc. So basically it's turning each star into a button, we could say. The tap gesture performs the action defined in the closure when a person clicks or taps a star image instance. Once again, I disagree with the usage of the word instance. The star indicates the rating that star rating assigns to the recipe. For example, if a person taps the fourth star, the recipe's rating is set to 4. So once again, I explained exactly what was already written. Tap the fourth star again, and star rating resets the recipe rating to 0 star. So what is the logic? And I think you're going to tell me, Wilfried, that this logic is implemented inside the view, which is not ideal because it makes it very hard to test, and this should be implemented in another struct that is not tied to SwiftUI. So for instance, here, having a struct like star rating config would have been kind of nice, or not even a struct, but maybe having, having this logic inside the static method could be nice, because this way you can test that static method in your unit test, even though it will still be part of a view, but you can still access the static method because the static method will only depend on its input and not on the whole SwiftUI framework being loaded and at work. So what's the logic? If the value is different than the current rating, so for instance, if the rating is 3 and we tap either 4, 5, 2, or 1, then the rating becomes the current value. So if the rating was 3 and I tap 2, rating becomes 2. If the rating was 3 and I tap 5, ratings become 5. However, if I have tapped the current rating, then the rating is reset to 0. Yep. That's exactly what I said, so I don't make any mistake. Okay. Step 3, section 3, display the custom control in other views. Star rating is ready to go. It has the data it needs, it can apply changes to that data, and it can visually represent the current state of the data in the app's user interface. The next step is to make use of the custom input control. So we have this regular title view, so a view that is displayed as a background overlay over an recipe. So in the sample app, star rating appears under the recipe title that appears in the recipe detail view. So the struct regular title view is a view that displays the title and subtitle of a recipe along with its rating. So we can see it as a binding to the recipe. Yes, so it has a binding to the recipe, so passed by some parent view. This binding allows the view to read and write data to an instance of recipe. Once again, it might be a value and not an instance. However, the view isn't the owner of the recipe. Another view in the sample is responsible for creating and owning the recipe value, not instance. Please stop. Step 3. The view shares a binding to the recipe's rating property with the custom control star rating, which allows the control to read and write that property. So what's an interesting pattern is that when you have a binding to a complex object, you can pass a binding to one of its properties by just doing $ in front of the object and then calling one of its properties. And that's one of the keys, one of the sugar syntax that makes SwiftUI code like clean, nice, and agreeable to write and read. As a person interacts with the star rating control, SwiftUI redraws the view to reflect the selected rating. So that's the logic we've seen just before. Important, the $ prefix on the variable name recipe indicates that the call is passing a binding to star rating. All right. Last chapter. Okay, we've covered quite some things, and I can tell you, like that pattern of having a kind of a small view model with mutating functions, I'm going to discuss it with my colleagues because I'm very interested by what I've learned this evening. So, defining the custom source of truth using a custom binding. That's interesting. And for a basic tutorial, it's ending with quite a complex with quite a complex example. Like honestly, like having given a SwiftUI training session, like this tutorial is kind of, it's not as much as what I was doing in my first day of the training session, which was 2 days, but it's like almost like a third of that. So you have it for free right here. If you want to learn SwiftUI, like do that with your team. You take like 2/3 of a day and you can do it. Yeah, it could be something very nice. So let me download the project. So here we learn how to provide an alternative to a state variable by using a custom binding. The most common way to define a source of truth that binds two other views in your app is to declare a state variable using the addState property wrapper. However, there may be those rare occasions when the source of truth is dynamic and can be defined using the addState attribute. For instance, this sample app needs to retrieve a recipe as a source of truth using the recipe's ID. The app accomplishes this by creating a compute property that returns a custom binding. That's interesting, because I don't think I've ever implemented this. Like, I guess when I'm going to see the code, I'm going to think that, yeah, okay, I've already seen that kind of pattern, but I don't think I've ever done this. So let me close the project, open the new one. I think I'm using it with, yeah, I was opening it with the normal Xcode and not Xcode beta. Okay, let's try and build it, and we'll see if I can build it or not. Yeah, it's not working. You definitely want to have macOS Ventura installed to do this tutorial and to run the code. Okay, so let's just scroll through the page. So first section, specifying the source of truth. This sample app displays the details of a recipe in the custom view detail view. The view only knows the recipe ID, but not the recipe. So it uses the ID to retrieve the recipe from the recipe box, a data store that contains all the recipes. Or it could be making an API call, that kind of situation where you have only an ID and need to retrieve the full data is extremely common. Because the view needs to retrieve the recipe, it uses a custom binding as a source of truth of the recipe instead of declaring a state variable for the recipe. Note, using a custom binding is a useful feature of SwiftUI, but isn't always the best option. Limit its use to use cases where using a state variable or object isn't possible in most cases. Define the source of truth as either a state variable for state local to the view or state object for shared data model to let SwiftUI manage the value or object for you. Oh, okay, so what they call a custom binding is when you create a binding by giving it an explicit getter and setter. So I've already used it actually, for instance, to create a custom API around the navigation. Like now we have navigation stack on iOS 16, but before we had navigation link, which sucked. And so I did a custom modifier where you could like set an item in a property and then navigate when that item was set. And so for that, I would have a modifier on navigate on changes of item, and I would need to create a custom binding for it. And so I've already like used it, and indeed it's not your go-to solution. It's more like for a custom. More complex situations. But I agree that when you want to make like some kind of, having a binding that would get and set to an API is kind of smart. And by API, it could be like either a local database or something over the network, anything that's where you have a get and a post, basically, like conceptually. To get the recipe value in the detail view, this sample implements the compute property recipe instead of declaring a state variable. So we have this private property recipe. So you can see it's computed, meaning it's not stored. It doesn't store data. Every time you call it, it will return, it will execute the code and return the binding. And the compute recipe property doesn't return a recipe. Instead, it returns a custom binding of type recipe. This allows the view to share the recipe as a source of truth with other views. A binding provides read and write access to a value. To provide access to the recipe value, the computed recipe property uses the init get set initializer method to create a binding. So basically, a binding is a two-way binding. A binding is a two-way binding, which is a fancy way of saying it's a couple of getter and setters, because you need the getter to get the current value and the setter to update the current value to a new value. And so here we have the getter in the first closure and the setter in the second closure. So let's see how they explain it. So the bindings get closure uses a recipe ID to retrieve a recipe from the data store recipe box. Okay, so it does if let ID, so if there is an ID in the recipe ID, it's going to do recipe box dot recipe with ID, and if there was nil, just return the empty recipe, and else just return the empty recipe. Okay, so it's going to just like under the hood, it calls recipe box. And the setter, so the setter, I guess I explain it just a little bit later. So in the set closure, the binding updates the recipe box with the new recipe value, updated recipe. So it does recipe box dot update. So it's like, it's like get and post. It's kind of a CRUD, basically, we could say. This update happens anytime data changes in the binding recipe value. For instance, after a person changes the rating of the recipe. That's interesting because even if one character of one string stored inside the recipe changes, it's going to call the setter. So if the saving a new recipe is cheap, that's okay. If it's a network call, you definitely don't want to implement it that way. So it's something that you want to keep in mind. There is no debouncing or anything like that being implemented here. Of course, you could set the recipe only when you want to save it and not like update it for every single character, but it's something that should be kept in mind. Then the detail view passes recipe to the recipe detail view as a binding value, which allows the detail view to read and write to the recipe value. So here it passes just recipe, and you can see that there is no $sign because this time there is no property wrapper. The recipe is a binding from the start. And so, for instance, if we did a recipe, it wouldn't be a recipe, but a binding of a recipe, and we will need to call get on it to get the actual recipe. And once again, it's exactly what is in the important block. So because the complete property recipe returns a binding, it is not necessary to include the $sign prefix that's required when passing a state variable as a binding. For state variables defined with a state property wrapper, the $sign prefix tells SwiftUI to pass the projected value, which is a binding. I mean, I guess it's a good sign that I'm able to like always say what is inside the notes, because it means I could be able to write that kind of tutorial if only I had the time to do it. Next step. So the navigation title modifier accepts string value, not a binding to a string value. So the view passes the recipe binding wrap value. So I was saying you need to call get. Actually, you need to call wrap value to have that get, but it's the same thing under the hood. A wrap value is the underlying value referenced by the binding. Since the computer recipe property returns a binding, its wrap value is the actual recipe value. So recipe.wrapValue.title gets the wrap value of the recipe binding, then it passes the title property of the recipe value to navigation title. Interesting remark I want to make here is that up until now we've seen top-down data flows. What's interesting is that navigation title, it's a bottom-up data flow because the child view says which title should be displayed by the parent navigation view. And I don't think we're going to see the mechanism that implements this, but I just wanted to say that the name of this mechanism is called preferences. And if you want to go further after this tutorial, you might want to check how it works. Okay, is it the end? Like it stops here? So I guess it's the end of the tutorial because there is no other section. It's a bit of, it's quite abrupt for the end. Yeah, because there was this next section, but this time there is no next section. So that's the end of the tutorial and also the end of the live. So yeah, 2.5 hours. I think that's a decent duration, especially like seeing how many different things we've covered. So I definitely very strongly recommend following this tutorial to get started with SwiftUI. You learn tons of stuff, top quality top tier. Basically, that's all I have to say after having followed this tutorial. I've learned things that are going to be useful for me in my daily work. So definitely recommend anyone having a look at the tutorial, whether you are a complete beginner or someone with some experience with SwiftUI. Just want to say thank you for having followed this live. Big thank you, Wilfried, for all your comments in the chat. This is what makes this live much more alive, and also which helped me not feeling like a completely crazy dude that talks alone in his office at night. So thank you all. If you want to follow the tutorial by yourself, you have of course the link in the description. And all I have to say is well, thank you for watching, and see you next time for another video or another live. Bye bye.